Bonjour et bienvenue à la séance de l'après-midi. L'après-midi a pour nom le corps en action pour une des approches. Je ne sais pas si j'ose dire le mot, mais bon, enfin bref. Et notre premier exposé va être fait par Maria Alessandra Umiltà. Et j'aimerais dire d'abord que c'est pour moi une belle journée, car entre autres choses, elle me permet de présenter des chercheurs que j'admire. Et Maria Alessandra Umiltà, je connais ses travaux, et elle fait partie de ces chercheurs. Elle est chercheure au département des neurosciences de la faculté de médecine de l'université de Parme, où elle a terminé en 2000 sa thèse de doctorat sous la direction de Giacomo Rizzolatti. Et si en plus nous savons que la thèse portait sur le cortex prémoteur ventral du singe macaque rhésus, c'est-à-dire l'F5, et que nous nous souvenons que Vittorio Gallese est professeur dans le même département à Parme, nous saurons tout de suite que Maria Alessandra travaille dans le cadre où ont été découvertes les neurones miroirs. Depuis lors, elle a poursuivi diverses pistes ouvertes par cette découverte. Le dernier article d'elle que j'ai lu, paru en 2013, porte sur le déni de la tristesse, sur l'impact des traumatismes de guerre sur la reconnaissance visuelle des émotions chez des anciens enfants soldats au Sierra Leone. Le travail de Maria Alessandra Umiltà est depuis longtemps d'une grande importance parmi ceux qui s'intéressent aux relations entre les arts et les neurosciences. Dans un article paru en 2001 dans la revue Neuron, elle démontrait que le système de neurones miroirs chez le macaque comprend un sous-système qui s'active lorsque la partie finale de l'action motrice dont l'animal est témoin est cachée. Alors, je n'ai pas fait de relevé systématique, mais il me semble que cet article, dont elle est le premier auteur et qui s'intitule « I know what you are doing, a neurophysiological study », a été et reste l'un des principaux points de départ pour aborder les conditions neurobiologiques de la performativité théâtrale et de l'expérience performative du spectateur. Aujourd'hui, elle nous parlera d'une autre ligne de recherche portant sur la manière dont la perception d'images statiques ou un mouvement met en marche le système de neurones miroirs. Elle soulèvera donc la question des manières dont le corps fait corps avec l'art et avec l'expérience esthétique. Alors, au nom de nous tous, je lui donne la bienvenue. Benvenuta, ti lascio la parola.
Very much. Can you hear me? Yes. So I'm basically, hello to everybody, I'm a physiologist of the motor system. So the other part of the story, if you compare with Margaret Livingstone. And I will try to explain you how the body and the motor system, the cortical motor system of humans is involved in art perception. And so the role of the motor cortical system in art perception and fruition. I'll start with a proposal about, I changed my position, of a definition, a personal definition, a very general definition of art that is a product of body movements. And so as this, I consider any kind of art as a particular expression of human behavior. And I will try to answer two main questions. How and is the body of the observer involved in abstract art perception? And another question, the second part of my talk, is whether the body of the observer is involved in movies perception. So, an important point is that, as I told you, artwork is an expression of human behavior, any kind of art. And me, personally, as a physiologist of the motor system and as a neuroscientist, I really wish to measure the brain activation elicited by artwork's presentation, but I'm not interested in measuring, and I think I cannot measure, the symbolic value of art. So just art as expression of body movements and human behavior without considering the symbolic value of art. So I'm going to start with a brief introduction about mirror mechanism in macaque monkeys and in humans. So what is particular of mirror neurons is that they have two kinds of discharges, two kinds of responses. The motor response and the visual response embedded in the same neuron. So they respond, the first time they were recorded in the ventral permotor cortex of macaque monkeys, and they respond during action observation. So when the monkey sees another individual, human being or another monkey, performing an action, for example, a grasping action, and the same neuron discharges also when the monkey performs a similar action as grasping action. So there is this matching, visuomotor matching between the two responses of the monkey. So interpretation of these double responses in the same neuron is that this is a basic mechanism that allows action understanding. So it's a mechanism that is not voluntary mechanism, is automatically triggered by the observation of someone else performing a similar action. So there is this visuomotor matching that could be, this is the hypothesis, the interpretation of the functional role of these double discharges, could be a mechanism at the basis of a direct form of action understanding. Because you have the same neuron and the same brain areas that are activated both when you observe someone else performing an action and when you perform a similar action. Of course, in humans, we don't record neurons, but in the last 10 years, our group and many other groups all over the world performed many experiments in order to investigate mirror neuron activity, mirror neuron mechanism. So we can say in humans mirror neuron mechanism, that is this matching between what you see and what you do, and is not linked only to the motor system, but also to other aspects of social life that are emotion, coding, and also sensory motor activation. So basically, the idea is that when you see activation of the same, you have the activation of the same brain region during first and third person experience of actions, emotion, and sensations. Another aspect that is going to be important in the next part of the talk is that the mirror neuron mechanism in humans for actions is not active only when you see someone else performing an action, but also when you see static images showing an agent performing an action. So you don't have to see a movie or a real person in front of you performing this action, but even the static images of a body movement are sufficient to activate the mirror neuron system activity. So there is this shared mechanism that basically automatically links the first and the third person experience. It's a capacity that we have to make sense of action, emotion, and sensation of others that depends on a functional mechanism through which the actions, emotion, and sensation we see activate our internal representation of the body states. So it's matching mechanism. So it's well known that the observation of a gesture performed by another individual activates the mirror neuron system in mirror neuron mechanism in humans. So our experimental question was, okay, we know about the observation of action and gestures, but what about the consequence of an action? If I see only the consequence of an action, is it enough? Is it sufficient to activate the mirror neuron mechanism activation in humans? So are the consequences of the motor act performed by another individual mapped in the motor system of the perceiver? For example, you can think about broken egg or just the consequence of someone else's gesture. So does the observation, not the gesture, not of the gesture, but of its visual, merely visual consequence, activate the same motor centers required to produce the graphic sign in this case? We decided to select a particular category of, and now I start talking about art, particular category of visual stimuli that were abstract artworks. The observed motor act, we know that is enough to activate the mirror mechanism in humans, but what about the here you can see Lucio Fontana performing the cuts on the canvas, and here you can see the consequence of this gesture. So we decided to use the artworks, abstract artworks of Lucio Fontana as visual stimuli to see whether they were able to activate the motor system of the perceiver. a very brief story about Lucio Fontana, and this is the abstract of the paper. So we use high-density EEG, and we measured as a parameter for measuring the motor cortical activation, the mu rhythm desynchronization or alpha rhythm desynchronization, and over the motor cortex of the observers. And we used two categories of stimuli because in order to demonstrate that one condition works, you have also to demonstrate that there is another condition that doesn't work. So otherwise it's very difficult. And so we modified the original artworks of Lucio Fontana, trying to remove any dynamic aspect of the cut on the canvas. So we tried to stimulate with a comparable graphic pattern, comparable symmetry, but without any dynamic component as the original. Again, I'm presenting these artworks of Lucio Fontana. I measured the brain activation elicited by their observation, but not the intrinsic symbolic value. So it's a very important point. So we showed two categories of stimuli, original artworks and control stimuli. As you can see, we presented, of course, were images of artworks of Lucio Fontana, not the real artworks, because they were too expensive, by the way. And with 1, 2, and 3, and here you can see the 3 control images. Here you see the experimental paradigm. Of course, the presentation was randomized, and we had also added an attentional task, but it's not that important. And here it's a topo map showing the alpha desynchronization. Here you see the activation of the motor cortex of participants during the observation of original stimuli. Here you can see C3 and C4 electrodes, and here the activation during the observation of control stimuli. As you can see, mu suppression was bilateral and mainly localized over the sensory motor areas. Mu suppression was much stronger, where you see, blue means activation, while red no, during the observation of the original artworks, if you compare with the observation of control stimuli. Here it's another it's apparently an experimental detail, but it's very important, is that we were, of course, interested in investigating whether participants, how much the knowledge about the art of Lucio Fontana could affect our results. So we divided participants in 2 groups on the basis of the score that they gave to the knowledge about the art of Lucio Fontana. And this mu rhythm desynchronization, this cortical brain activation we had during the observation of original artworks was completely absent, was not completely irrelevant. The factor familiarity was considered in the statistic, but was not significant. So it means that this activation during the observation of the original artworks of Lucio Fontana was not related, was not dependent from the familiarity. Here you can see familiar and unfamiliar, and the amount of alpha desynchronization that was not dependent at all from the familiarity of participants with this kind of artworks. So we can conclude that the consequences of a motor act performed by another individual are mapped in the motor system of the perceiver. Maybe we hypothesize in a way that simulates the gesture of the artist. Another aspect that we considered was to score also the aesthetic appraisal the participants showed for the original artworks compared with control stimuli, asking them how much do you like this image, and participants' aesthetic appraisal was higher for original artworks than for control stimuli, in both groups of participants. And we also asked another question that was, if and how much movement do you perceive in this image? Of course, participants were quite skeptical. What do you mean with movement? I cannot see any movement. But anyway, we forced them to answer to this odd question. And again, the amount of movement perceived was much higher for original artworks than for control stimuli. So, our interpretation is, why should the observation of a static image like cat in a canvas activate the observer's motor cortex? Our interpretation is that this kind of images activate the motor representation of the same gesture in the brain of the beholder. So also we can add something to the neuroscience of art perception, that is that beside the observation of dynamic or static motor acts that was already known in the literature, also the observation of static consequence of a motor act is capable of activating its motor representation in the observer's brain. Then the second, this study is not done by our group, but from another group, and it's just a behavioral study, but on my view it's very interesting because it links art perception with aesthetic appraisal and with body movements. This sentence is from the authors Leder, Barr, and Topolinsky, and they wanted to test whether art appreciation was related. I try to explain you, it's quite complicated. So they showed to participants two categories of stimuli, two categories of artworks. One was performed by the artist, then I will show you the list of the artworks employed in two different painting styles. One was pointillism and the other was stroke style paintings. And participants were asked to perform two kinds of movements that were tapping, that was the movement very similar to the pointillism style, and strokes with this pen, that was a movement congruent with the other painting style. And during performing these movements, they had to score, to rate the aesthetic appraisal for these categories, two categories of artworks. So the experimental conditions basically were two: congruent when a matching occurred between hand movements and painting style, and the other one not congruent when painting styles were different from the executed movements, of course. Participants always, for all stimuli, aesthetically judged all the artworks. Here you can see the list of the two categories of paintings, visible dot point patterns and visible etchings, from Van Gogh, Serrault, and others. The conclusions of these experiments, the results, show that the rating was a function of the style of the paintings and the type of movement participants executed. So they saw this relation between aesthetic appraisal, body movements, and art perception. They said, our results show that even static materialization, the painting style of an absent artist's action, can influence viewers' experience and preference. The present findings show how artistic style, as a concretization of the artist's act creation, links the artwork's creation with the moment of art perception. So in my view, it's just behavioral. They did not measure any brain activation, but it's an important step forward for art perception and for linking art perception with body movements. Here is another study we performed, and in this case, we use the same technique, EEG, high-density EEG, but in addition, we also try to localize the brain activation. So we performed a source localization of the recorded signal, and we used a different categories of artworks. We aimed to offer a closer assessment of the involvement, in this case, of the sensory motor cortical circuits during the beholding of static consequence of hand gesture, devoid of any meaning. I show you the stimuli. We were interested in detecting specific cortical areas, so we performed this this source localization activated by the observation, in this case, of brush strokes. Okay, here you can see the stimuli we employed, and why we choose Franz Klein, for two main reasons. The first one was that in his artworks, the traces of brush strokes were very evident. So you can see color dripping, different pressure of the brush, and the other reason, we considered them as clear consequence of a human gesture. And the other reason was quite a bit more experimental reason, that was possible to make also control stimuli, reliable control stimuli, because we considered the option of Colloque, of other artists, but creating control stimuli when you have so many graphic signs, it's quite impossible. So we decided from Franz Klein that was a good compromise between our experimental question, our aims, and good artworks with clear brushstrokes signs. And here you can see the two categories again, original artworks and the control stimuli. And here the work selected as stimuli for the experiment are characterized by a small number of brushstrokes, allowing us for an easier construction of 3 reliable control images. As you can see, again, the graphic pattern is similar and the symmetry is similar, the thickness of the signs are similar, but we tried to remove any dynamic aspect in the control stimuli with respect to the original artworks. I try to better explain here. We tried to the same, similar, I cannot say the same, but similar thickness and length, keeping the same graphic pattern and symmetry, but the modified stimuli were designed with an intent of removing the visible consequence of the artist's gesture, drips of paint, blurred contours, difference in pressure of the brush, etc. Again, it's a level of description, of course, when, as a neuroscientist, when you try to investigate how the art perception activates the brain, you have to start from very simple level to simplify everything, and anyway, keeping as much as possible ecologically plausible the stimuli employed. Here you can see basically the results. This is an ERP, event-related potential, during the activation, the observation of the original artwork, this is the blue line, and during the observation of control stimuli. Here you can see that this difference between the two categories of stimuli, it's evident in the frontal electrodes, in central electrodes, but less here in parietal electrodes. So the ERP recorded during the observation of paintings could represent the cortical motor representation of the hand gesture, whose consequences, the brushstrokes, are directly observed by participants. Here, the results of the source localization. we had a significant activation of parts of the brain that belong to the sensory motor circuits that are superior parietal, here and here, and primary motor cortex, inferior parietal, and also the premotor cortex. Also in this case, we asked to participants to rate for the aesthetic appraisal and the amount of movement, and both parameters, amount of movement and aesthetic appraisal, were higher during the observation of artworks significantly, comparing with modified stimuli. So we are about the cortical sensory motor activation, so the localization of the source of the activation, for us is a fundamental neurophysiological demonstration of the direct involvement of the cortical motor system in perception of, again, static, meaningless images belonging to abstract art. Sensory motor involvement, in our view, is directly associated with the presence of visible hand traces. So the result is that the brushstrokes are responsible of the activation of the sensory motor areas, controlling the motor act that led to their production. So again, it's the activation of the same gesture performed by the artist when it was creating the artwork. So again, we demonstrate the involvement of the motor system during abstract art observation. Even it's, of course, devoid of any explicit movement image, because participants didn't see someone moving. It was not a static image of a body moving, but was a static image of consequence of body movements. So the second part of my talk is dedicated to another aspect of visual art, that is cinema. And we performed this study in order to investigate whether mirror mechanism in humans was modulated by the observation of different filming styles. I can say a neuroscientific approach to an aesthetic issue, that is filming styles, and we employed 4 categories of movies. And the movies showed always an actor performing an action that was grasping. And but what was different? What was different was the way of the camera approaching the scene, because we filmed the scenes with four filming techniques, so 4 different camera movements. So we wanted to investigate if the mirror mechanism was different, the activation of mirror mechanism was differently modulated by different camera movements. So the first one, of course, were randomized, is dolly. It's basically it's a camera mounted on tracks. I show you some examples of the stimuli to give you an idea. This is the still. For what we know, until now, all the studies on mirror mechanism activation in humans was done with still. The stimuli were prepared with a still camera. So this is the classical way in which the participants of all the experiments see the gestures. Does not work. No. My computer does not wait. I can see. Yes. It's crashing. Okay. No, look. does not answer. It's Microsoft PowerPoint does not answer. I'm doing. Okay. Okay. So. Okay. Dolly. Okay. Let's try with still. Okay, now it works. You can see, in this case, the camera did not move. Zoom. So the camera was in all conditions except still camera approaching the actor, approaching the scene. The zoom was the most artificial, of course. And finally, the most interesting condition was that one. That was the Steadicam. The Steadicam, it's mounted on the body of the operator. So while the camera moves together with the body of the human, and we considered it as the most ecologically plausible way of approaching a scene, because was filmed while the operator was moving, so more biological. I show you some other examples. Again, Dolly. So you can see the difference between the camera while the camera moves and stays still. Experimental paradigm. So we also asked to participants to give answers to identity of the objects, but was not important. Here you can see the results, but I'll try to explain you better. So the observation of the movies filmed by means of a Steadicam was the most effective in sensory motor cortex activation. The still camera was the less effective, and Dolly and zoom were clustered in between. I try to show you here. Here you can see this is the amount of event-related desynchronization, of alpha desynchronization, during the condition of Steadicam. The desynchronization is that lower it is, most effective it is. So here you can see the Steadicam was the most effective. The still camera was near to the baseline, so was basically effective because activated the mirror neuron mechanism, but was much less efficient in elicited ERD, event-related desynchronization. And here you can see the two other conditions that in between that were zoom, the red one, and Dolly, the green one, that were clustered together and were in between the still and the Steadicam. The Steadicam was used for the first time, was not invented by Stanley Kubrick, but was used for the first time in The Shining. So it's quite recent. So the observation of the movies filmed by means of a Steadicam was the most effective, as I told you. We also asked to participants, we wanted to investigate whether the different viewing conditions could be related to participants' subjective reports regarding the feeling of involvement and they experienced, how much they felt natural or artificial, the different camera movements. We wanted to measure participants' estimation of the ecological plausibility of the different types of camera movements by means of different questions. So the first one was, how much did you feel involved in the scene? And participants felt more involved in the scene when the camera was approaching the agent in comparison to when the camera was still. Of course, here you can see the still and the other three movements. So in general, when the camera was approaching the scene, they thought that they felt more involved in the scene. The other question was, how realistic did you find the camera movement? Of course, in this case, we did not ask for the still camera. And again, found the camera movements more realistic when the Steadicam was used. As you can see, was significantly different from the other two conditions. And the last question we asked was quite complicated, was how much do you feel the camera movement resembled a person's movement when approaching the scene? And again, participants found the camera movement more resembling person's movement approaching the scene when the Steadicam was used. You can see it was significantly different from the other two, always clustered together. So it's clear that participants rated the movies, those movies in which the camera approached the scene, as more involving than those of still camera. And also, they considered them the most natural and most resembling the movements of approaching observer. So maybe eliciting the feeling that the observer himself or herself would walk toward the scene. So were more ecologically plausible, more realistic, more embodied with the participants, with the observer. So we can say that the results of this study demonstrate the utility of a more ecological designed study for exploring visual art perception. And we think that maybe this effect we found with Dolly is that its activation is maybe it's an activation of the mirror neuron system. And this more embodied camera movements enforce the activation of this mirror mechanism. And maybe also our hypothesis is that the Steadicam produce a visual experience closest to the normal human vision during movement. When we approach a scene, when we approach someone else, we have a visual activation that is very similar to this. I go to the conclusion. So the conclusion of my talk are that the perception of visual abstract artworks does not imply, do not only involve visual cortical areas. Our study demonstrated that visual abstract artworks perception elicited the activation of sensory motor circuits. We can say that during visual art fruition, perception and action are not separate domains implemented in different anatomical and functional circuits, but they are together, embedded, linked together in the same circuits. And we can say that we don't simply perceive visual art, but action itself contributes to the perception of visual art.